This exercise, we have to determine the Miller indices of a reticular planes. Take the plane P1. We have to determine the intersection of this plane with the axis A, B, and C. We show here that this plane P1 intersects the axis A in the position 1A, and we say that the intersection of this plane with the A axis is 1A. The intersection of this plane or with the B axis is also 1B. And with the C axis we have 2C here. This intersection is from the origin at 2C. And we say that we have 2C as intersection. We take now the inverses of intersections and we find 1, 1, 1 whole. As we have here a fraction, we multiply by a multiplicative factor to have integer numbers here. This multiplicative factor is equals to this number here, to the denominator of this fraction. And if we multiply by 2 the three inverse of intersection, we find these integers 1, 2, 2, 1. And we now seek what is the greatest common divisor for these three numbers. We obtain that for these three numbers, we have the greatest common divisor is 1. So we say that these three integers are coprime integers, and we note these coprime integers as 2, 2, 1. As these integers are coprime, we say that these numbers here as the Miller indices of this plane. And we say that this plane has as Miller indices 2, 2, 1. Now we go to the plane P2 and we say that with the axis A we have 1A and the intersection is equals to 1. With the B axis here, the plane is parallel to this axis. The plane is parallel to the axis B. And we say that this plane cut the axis B at infinity. Now for the C axis, this plane P2 cut this C axis in 2C. 1, 2C. And we say that we find that the indices of this intersection as like this 1, 0, and 1 half. The multiplicative factor to find integer numbers from this is 2 here also, because we have a fraction with 2 in the denominator. And we find the integer numbers which are 2, 0, 1, and the common divisor here is also 1, and these numbers are the coprime integers. So this numbers are the Miller indices. For the plane P3, we have to do a change in the origin to find the intersection. We change the origin from here to here, like this. And now we show that the plane P3 cut axis E in 1E, yeah, is parallel to B, like this, parallel to B. So it cuts B at empty, and the C axis is cut by the plane at 1C. So we seek for the inverses of intersections. We find 1, 0, 1. The multiplicative factor is here 1 because there is no fraction here. So the numbers are the same, 1, 1, 1, 0, 1. The greatest common divisor here is also 1. And we find the co-prime integers, which are the same numbers, 1, 0, 1, which are the Miller indices H, J, L of this plane P. We go to the plane P4. Here we have also to do a change in the origin. We place the origin here, this, and now we show that this plane P4 cuts A here, B here, and C here. So cuts A in 1A, intersection is 1, cuts B in 2B, and it cuts C to 1C. The inverses of intersections are 1, 1/2, 1. Here we have a fraction. We have to multiply by a multiplicative factor, which is here 2. And we find the integer numbers 2, 1, 2. The common divisor, or the greatest common divisor here, is also 1, and we find that the three co-prime integers are 2, 1, 2, and are the Miller indices. For the plane P5, we have to do a change of the origin of the axis, and we place the origin here, like this. And now we have to determine the intersection of this plane P5, with the axis A, B, and C. With A, we have that we note that the plane P5 is parallel to A, and we say that this plane intersects A at empty. For B, the intersection of this plane with B is -2, 1, -1, -2. And with C, we have +2. The plane intersects this axis here, which is at 2C. Now we take the inverse of these intersections, and we find 0, one half and one half. We take as multiplicative factor the number 2 because we have here one half, and we determine the integer numbers which are 0, -1, 1. And here for the three numbers here, we have the greatest common divisor is 1. And by dividing these three numbers by 1, we obtain the same numbers here, 0, -1, 1. And we say that the Euler indices are h equals 0, k equals -1, and L equals 1.